Okay, so for question one, or question three, so it goes up 15 meters per second in 3 seconds, and then maintains that speed for another 4 seconds, and then starts to come to a stop for another 3 seconds. So my graph would end up looking like this, and then I would shade it in like that to complete the question. Okay, and then for question four, I could determine how far the car traveled using the velocity time graph right here, because in the question it says it accelerates 15 seconds, and then it tells me how far the car travels per second and how when it slows down. So using that, I was able to determine how far they went. And then for number five, so a car can move at a constant. The car cannot move at a constant speed and still be accelerating, because the car must stay the same speed to be constant. And here, this is not constant because it starts and then levels out and moves at a constant speed, but then drops and stops. So it's not a constant speed for number five. All right, so after reading the question, we figure out we are looking for the final position. So first, we fill out our kinematic equation. So easiest one to start with is time. So it would be 0.8 seconds. And then acceleration, meters per second squared. And then we are looking for the final velocity. So that would be 0 meters per second. The initial velocity would be 3 meters per second. This would be 0. Okay, so now we do that. And after filling this out, we realize this is our equation to find the final position. So if we fill that out, look like this. All right, hope you can see that well. So then we start solving it. Times 0.64, then keep on solving it. 0.2, and then after doing that, we would find our final position would come out to 1.2 meters. All right, so for question 8, I have to plot a velocity time graph, and so I plotted it, and so you can see the variables I had to use. I plugged them in, and so it has positive slope going up. It keeps accelerating from the starting point of 0. And so B asks, was the acceleration of the car constant? And it is constant because the graph shows that for each second, the velocity increased, like from 4 seconds to 5 seconds, the velocity increased 2 meters per second. So it's increasing 4 seconds it's increasing 4 meters per 2 seconds. So that's how the velocity or the acceleration is constant. And so then C asks, how far did the car travel in this time period. So we have to use the kinematic equations. So I'll fill it out. So starting position, assume 0. Initial velocity is 0. And then ending velocity is 22 meters per second. And then acceleration, we don't know acceleration initially from the question, so we have to do a kinematic equation for that. Then time would be 10 seconds. So for the first, so we don't know x, or we don't know final position or acceleration. So we have to do one of the kinematic equations for this. So I filled it out. So it'd be v equals xt. Okay, so that's our kinematic equation. So we just plug everything in like that. All right, then we solve. So basically it'd be 0. So we just want to divide the 10 over here. So then that would end up giving us our acceleration of 2.2 meters per second. So like that, squared. Yeah, squared. And then then we can use the other kinematic equation. So there it is. It would be, okay, so then I'll plug it in up top. So we're looking for final position, so we'll use the second kinematic equation. Okay, so I think hopefully you can see that up top, running out of room. So then we solve that. So it'd be like, so because of the zeros in front, the 10 would cancel out. So then it would leave us with half times 2.2 times 100. So once we do that, it would be 1.1 times 100, like that. And then we'd solve that, and that would make it x equals 110 meters. So our final position, or the car, how far the car traveled during this time period, it would be 110 meters. All right, so for question number 12, final question, I asked how long it would take for a bowling ball drop 3 meters above to hit the ground. So first, looking at this, it's a free falling. So we have to fill out the kinematic. So for initial position, it's 3 meters in the air. For finish, it's 0 meters. And then for initial velocity, it's 0. And then for ending velocity, we don't know. And then, or no, starting velocity, we don't know. And then, no, sorry. Ending velocity, we don't know. Starting velocity is 0. And then acceleration is minus 9.8 meters per second squared. And then we're looking for time. So we go to our second kinematic equation and we plug everything in. Then we start solving it. So then we bring this over like that and divide it. Then that will bring us to 0.612 equals time squared. And then so to get rid of the square, we have to square root. And so it would bring us with 0.78 seconds from the starting position where the bowling ball was to hit the ground.